All right, so sustainable living. This is a way of living that considers how social behaviors and habits impact the environment, also while considering supporting a better quality of life for everyone. Hello, everyone. For the next 40 minutes, we'll talk to you about how we can make our buildings, our transport, and our cities more sustainable. Now, for a little bit of context, our transport and our buildings contribute to 50% of our total global emissions, and therefore they're equally important in our decarbonisation efforts. However, while these might seem unrelated, these overlap in our cities and our communities, and today we will explore how. With nothing further from me, I will pass it to MJ, who will introduce the first topic, which is transport.
Hey everyone. So in the context of transport, we often talk about 15 strategies. So we have improve, which is to enhance the current methods. We have shift, which is to move toward a more sustainable mode of transport. And we have avoid, which is to reduce the need of transport. My work today will focus on the improve strategy. I just have a quick question for you guys. How many of you have traveled by plane in the last 4 years? You can raise your hands, please. Thank you. So that means that you're part of the 2 billion people who have traveled in the EU in the past 4 years. Aviation is a good thing because it creates jobs and it boosts the economy. But it's also a bad thing because it creates emission. Between 1990 and 2014, there's been an 80% increase in emission, and there's an expected 45% increase by 2035 if no action is taken. Now, why do we travel by plane in the first place? Some of us travel for holidays in Spain. Some of us just visit family and friends over for events or for business. But at the end of the day, it all comes down to one factor, which is money. The reality is you guys wouldn't travel by plane unless. This is why GDP per capita is the key driver of aviation demand. As you can see on the top graph here, there's a clear correlation between the EU aviation growth and the EU GDP growth, with a drop in GDP in 2010 leading to a drop in the EU type growth. Similarly, there is a strong correlation with the population as well, because the larger the population, the larger the number of potential passengers is. Now, what's the aim of the project? Now, the project has 2 aims. The first one being to forecast aviation demand by 2050, using a polynomial regression modeling to estimate the aviation demand as a function of the GDP and the population. So this is the equation that we are trying to achieve at the end. And basically, we want to replace the GDP and the population by future forecasts using SSPs. Now, SSPs stand for Shared Social Economic Pathways. They are estimate scenarios of how likely the GDP and the population is going to be in the next decade or so. So as you can see, these are displayed on the screen here. Now, the second part of the project is to evaluate the effectiveness of technologies to reduce emission in aviation. The baseline scenario was created using SSP2. Why SSP2? Because this is the most likely scenario to happen out of the 5 SSP that I've shown before. We want to see what will happen if people stay at home and don't go for holiday for a while. So that will be the first scenario. The second scenario will be SAF implementation. Now, SAF stands for Sustainable Aviation Fuel. So if we replace kerosene by more sustainable fuel, what is going to happen to the emissions? We want to see what will happen if the EU ETS has higher carbon prices. And finally, we want to see the impact of hydrogen as a fuel for craft. Now, remember my first aim, the aviation demand. This is the result of the forecast. So we have SSP1 to SSP5, and SSP5 is the highest one. In this scenario, we have 5 billion people traveling in the EU. And in the worst case scenario, which is SSP3, we have around 1.5 billion people traveling in the EU. Now, as you can see, it's strongly correlated to the GDP because the GDP is increasing on the scenarios and the population, the passengers are also increasing. Now, for the expected reduction from the scenario that I mentioned before, hydrogen has the lowest potential with only 6% reduction. Modal shift and EU ETS both are at the tie with a 16% reduction of emission, and SAF which also again stands for sustainable aviation fuel, has the biggest potential with 30% reduction of the total emission between 2025 and 2050. Now, what's the conclusion for all of that? Aviation can be decarbonized, however, it really relies on SAF. Now, SAF has many challenges, including the limited feedstock and the high prices, will make it difficult for it to be implemented. This is why SAF cannot be used on its own. It needs a mixture of policies and other technologies. And I did mention that one of the challenges of SAF is the high price. So now I'll hand over to my friend Mohammed to explain how we can reduce the price of the uptake of biofuel. Thank you.
Thank you, MJ. So one of the reasons why the sustainable aviation fuel is expensive and has high costs is the need for upgrading it. And that need emerged from the fact that pyrolysis oil are not meeting the standards that are expected in aviation. So why it doesn't meet the expected quality is because pyrolysis oil in itself has very intricate chemical makeup. And on this bar chart, you can see some of the representative chemicals that may be found inside the pyrolysis oil. And this depends mainly on the biomass that is used as the feedstock for the pyrolysis reaction, and also depends on the temperature and the heating rate during the pyrolysis. All this complex chemical makeup leads to issues such as low energy density, corrosiveness, high oxygen and water content, and also the high viscosity. Additionally, all this complex chemical makeup makes the bio oil, very prone to polymerization, which causes to transportation issues when stored for a long term inside a storage. In my research project, I looked at the electrochemical hydrogenation of pyrolysis oil as a method of upgrade. And because it is very costly, what I did is I analyzed the chemicals that are found inside the pyrolysis oil, and I looked at their market data and so as an attempt to improve the quality, we need to remove some of the chemicals inside the pyrolysis oil. I assessed what are their market price, current and future, in 10 years' time will be. And for instance, for the sake of presentation, I will be sharing with you only guaiacol and phenol example out of the complex research, and where guaiacol reduction to phenol can be one way to increase the quality, to improve the quality of bio oil, and that helps to the stability of the pyrolysis oil. Hence, if we look at here the data shows us the market price and global demand for both guaiacol and phenol in my example, and the total market, if we remove guaiacol through reduction to phenol, increases. Hence, looking closer, if we look closer to the specificality of the process overall, I made a MATLAB-based modeling, and where I identified that the catalyst selectivity of the process and the hydrogen evolution reaction of the hydrogen evolution reaction Faraday efficiency are affecting the cost of the upgrade. Hence, if we develop a electrochemical hydrogenation reaction to have a low hydrogen evolution Faraday efficiency and high product selectivity, in my case, which is phenol, then we can reduce the cost. What would help to reduce the cost is also the current density, which you can see here up till 2000 would affect the price very rapidly. Using all these findings, I created to visualize the cost reduction. I created a waterfall chart, and from the base case scenario, which is the current situation, which based on the current situation of upgrading, we can see that if we increase the current density from 500, which is the base case, to 2,000, it will reduce the cost. And in the same manner, some cost reduction will happen if we reduce the hydrogen evolution reaction, Faraday efficiency, and also increase the product selectivity in our electrochemical system. So all this will add up to the enough cost reduction of glycol reduction to phenol to make the end product, which is for purifying is a byproduct, spot price to be below the actual price of phenol, hence making this approach, this strategy, economically viable. In conclusion, if we choose the right strategy in upgrading of bio-oil for sustainable aviation, and if we manage to bring in the industrial scope, the levels of product selectivity of catalysts and the electrolysis of the Faraday efficiency of the electrolysis, then we can achieve the low-cost upgrading. Now, Veronique will speak about the shift strategy in the context of net zero logistics.
The total cost of ownership, TCO, analysis of electric heavy goods vehicle, then electric trucks. Well, so what does it matter? The electric trucks or the trucks from logistic transport is responsible for 25% of global related transport emissions. And this has not changed for the last decade or so. But we already know that there are alternatives, such as electric cars, for example, to decarbonize transport. So why is it still so hard to decarbonize logistics? Well, there are three main drivers to this, which is first the high cost of electric trucks, second, the lower range of electric trucks, which means that they cannot easily transfer and support the longer range of logistic transport. The third reason is that a lot of uncertainties still remain for the operators in terms of how much should we invest and how should we even invest. In light of this, my research focuses on providing a comprehensive assessment of the cost to electrify heavy goods vehicle fleet with incorporation of infrastructure and also considering two investment models. So this research will be based on a real fleet study, but you can see the details here, and we'll investigate two investment models. The first model, purchase model, which is also referred to as DCF from the research, and the lease model, which is organized for 7 years transition. Well, diving right into the result. The first thing we look at is the infrastructure consideration. So if we look at the cost components of owning the trucks and operating them, we see that a significant additional investment for electric trucks compared to diesel trucks is the infrastructure consideration, which contains the chargers and the electricity connection. This additional investment leads to an increase of 13 to 20% in both the capex and the opex of the electric trucks. And as a consequence, of course, the still will increase. But what is the effect on the cost competitiveness of the trucks compared to the diesel counterparts? The main effect that you can see, the first thing that you can see from this table, which is the cost parity analysis between diesel trucks and electric trucks. We see that with consideration of infrastructure, currently with the modeling that we use, one truck size out of 3 analyzed reaches cost parity already with the diesel counterparts. Another thing also you can take from this table is that when using the trucks for 2 more years, the gap between the diesel trucks and the electric trucks, with highlighted kind of gap, is lower. As you can see that the number on the top of the table is lower, is higher than the number at the bottom of the table when used it for 7 years. So now we see that incorporating infrastructure, which is essential, by the way, for electric trucks, leads to significant increase in cost. But how is the investment even made? How to invest into trucks? Well, this is what it looks like to invest into a heavy goods vehicle, electric heavy goods vehicle trucks for 7 years through leasing. This is the assessment of an annual cost that the operator should be ready to invest, and the total cost, of course, of £57 million by leasing progressively. And this is the assessment of the total amount of emissions that they may be able to displace over the seven years if leasing progressively, and for the whole fleet, this is the total of emissions displaced. So there is an advantage, significant environmental advantage by choosing the electric trucks. But how does this leasing compare to purchasing the electric trucks and even to maintaining the diesel fleet? That's what we see here. The main thing that we can take away from this graph is first that leasing the truck, of course, will lead to short-term savings because then you're not putting that much capital in the beginning. So by 2034, we see that this number, which correlates to the total of these small green boxes here, is the lowest by 2034 when you are leasing the trucks. But then by 2040, which includes all the costs which remain even after the 7-year initial transition period, is 22% higher than when you purchase the trucks, and up to 60%, almost 60% higher than just maintaining the diesel fleet. But we know that you cannot maintain the diesel fleet because by 2040, you can't buy diesel trucks anymore. So it's essential to invest, and operators need to start early and carefully plan. Another thing I want to note here is that if you look at the sensitivity of how much more savings you can make from having lower electricity prices, by leasing the trucks, the effect on leasing the trucks is higher with lower electricity prices than with purchasing the trucks. So with a more favorable electricity prices environment, there is more benefits in leasing the trucks. So what should we take away today from this whole presentation is that electrifying trucks is a promising, at least short-term, option to decarbonize the heavy goods vehicle transport, but this still needs the involvement of all stakeholders to maintain a sustainable electric trucks vehicle sector by reducing electricity prices and carefully planning to invest into infrastructure cost effectively, and also to plan the best investments that they would like to use. Now that we have talked about decarbonizing transport, which makes cities open, Sophia and Yohan are going to tell us more about how to make our cities more sustainable.
Thank you, Veronique. Hello, everyone. My name is Yohan. Effectively, the challenges related to transport are particularly crucial in urban environments. Who in this room would like to live in a safe and pleasant environment? Who in this room would like to live in a city that fosters both individual and collective well-being? I would be very surprised to see one single hand going on. With 70% of the global population expected to live in cities by 2050, challenges related to transport present not only challenges in mitigating climate change, but also triggers urgent pollution and public health risks due to the massive use of cars. So how do we address that? Well, shifting away from cars to active modes such as cycling and walking are actually a key solution to build a more livable cities. Yes, yet cycling today remains quite underdeveloped in many cities, which underscore the need for targeted policies intervention in order to encourage more people to hop on the bike. And you know what? This is exactly what the French city Lyon is currently trying to do. Lyon is committed to reach net zero emission by 2030 and plan to reduce car use by promoting cycling. In practice, they want to develop 12 new cycle paths, safe and continuous cycle paths, by 2030, which extend to the suburban area, as you can see here on the map. But this context raises an important question. What would be the impact of such infrastructures? Well, For decision makers, this is a really hard question to answer because it requires a deep understanding of the complex interplay of factors affecting cycling propensity and transport choice, such as topography, infrastructures, demographics, cultural context, etc. So to investigate this kind of urban policies impact, agent-based modeling, or ABM, stands out. Why? Simply because it enables to represent a complex system. It's a computational tool. It enables to represent like virtual city with individuals interacting with their environment. It enables to simulate individual behaviors and decisions to then identify people reaction to policy intervention. Yet today, ABM for cycling policy assessment remains very rare. This is why this research focused on designing a proper agent-based modeling for cycling policy assessment in the case study of Lyon, specifically for commuting trips. So 3 different scenarios were assessed. The first one looked at the implementation of a generalized e-bike subsidy scheme for everyone. The second one looked at the implementation of the cycling infrastructures described before. And the third one is just a combination of both. So now you may wonder, how do commuters hop on their bike after policy intervention? Well, first looking at the modal share, it's clear that both e-bike subsidy scheme and new cycling infrastructures boost cycling uptake up to 17.2% in scenario 3 compared to 3.5% in the baseline scenario. But what is even more interesting is that by combining both policies in scenario 3, the impact on cycling uptake is even greater than the sum of their individual effects, which suggests that the importance, which highlight the importance of mixing policies to encourage more people cycling. It's also worth mentioning that most of the shift to cycling comes from a shift away from public transport use rather than from cars. And this results drastically the greenhouse gas emission reduction potential because Lyon already has a very low carbon public transport system. Now looking at the distance distribution, it's also clear that every scenario encourages people to cycle longer distances. However, like up to 50 kilometers, yeah. But however, for larger distance, the travel remains still very rare, which suggests that even with supportive policies, distance may remain a great obstacle to long-distance cycling uptake. Focusing now on scenario 3, you can see here on this map the distribution of the cycling uptake across the studied area. What stands out is that the cycling uptake mainly occurs in areas with high population density, mixed land use, flat terrain, and dense cycling infrastructures, mainly in the central area here. Zooming now into the central area, this map here informs decision maker about the traffic variation, the cycling traffic variation between baseline and scenario 3. It shows the potential future busiest paths, and which helps decision makers to identify the potential future congestion and then adapt their cycling infrastructures. So in conclusion, agent-based modeling is effectively a valuable tool to support and inform decision makers for urban planning and design and promote effectively cycling. After assessing different cycling policy, it highlighted the need for using mixed policies to leverage their synergies to make car less attractive and to abate greenhouse gas emissions. Finally, it identified that investment for infrastructures should be prioritized in central areas where the impact is the greater. While ABM is effectively a powerful tool to support decision makers, there is also a need to make decision-making process participative. It means by including people. This is the issue Sophia has investigated and will now present to you. Thank you.
Yohan? So, reducing urban transport demand and encouraging more active mode shares is really dependent on effective urban planning. But even the best intentioned plans can fail if they're rejected or ignored by local residents. As a result, planners are seeing the increasing importance of local participation in urban design. Participatory planning is a way to allow ideas to be community-led, and it's more effective at making sure plans meet local needs, and it ensures that plans are representative of the wider community. But despite these benefits, current participation levels are at an all-time low. So researchers are looking for more innovative methods to increase engagement, with one such method being video games. So In the context of participatory planning, video games are either academic or commercial in context, both of which have their own challenges. Academic games tend to lack the resources to reach a useful standard, while commercial games are entertainment focused, not focused on entertainment rather than planning, so they often aren't applicable or realistic enough. But the City Skyline series actually fills a very unique gap in this by overcoming these barriers. It's a commercial game, so it's had the ample development resources to make it usable and friendly, but it is relevant to this application because of its focus on urban design. It even uses a stylized angel-based model like Yohan discussed to simulate systems. Furthermore, it supports game modification, which means that the in-game model can be adjusted to enhance realism or remove developer bias, which is a limitation for many other city building games. As a result of this game has actually already been used in multiple academic studies on planning. And has even been used by real governments in Sweden and Finland to support real planning events. So these screenshots show a district in Stockholm that was recreated as part of a planning workshop in Stockholm in 2016. So my research builds off of this by exploring the potential of its sequel, City Skylines 2, which was released in late 2023, and also explore some of the more practical details of how game-based planning events would work. So my research basically had 3 findings. In terms of participation, I wanted to find out how games actually can increase participation. Sorry, that was weird. Anyway, so I conducted an online survey that asked over 2,500 respondents how willing they would be to take part in various planning events. And I found that overwhelmingly, especially for the more involved events like workshops or competitions, game-based events were significantly more popular, even people who hadn't played video games before or hadn't played city building games. Secondly, I assessed City Skylines 2 as a visualization and design tool. And I compared it to other available tools and found that it significantly outcompetes all available tools in terms of having advanced 3D graphics, intuitive user interface, and in terms of having a larger range of detailed design features. This was also further demonstrated by hosting a live online event that used City Skylines 2 to allow people to design an event, a city, the way they saw fit. I had 100 live viewers and further proof that this tool is capable of visualizing city development. This is an example, for example, just of how you can reallocate road space in the game to favor public transport and pedestrian modes. Finally, beyond visualization, the game is also capable of participatory modeling, which means that people can engage with the model to test solutions and get real-time effects, see the real-time effects, which enhances understanding and allows more meaningful contribution. City Skylines 2 is very well suited to this due to the AGM's model it uses, and a comparative analysis to academic models found that it actually contains all the key features needed to reflect land use and transport systems. Furthermore, because it has a really wide range of features, it's actually better suited for more flexible scenario testing. While it can't be truly accurate without data calibration, the way academic models are done, it does at least reflect real-world systems, which is all that you need for participatory modeling. But as with anything, there are considerations that need to be made for the game to be used successfully. Firstly, to ensure representative participation, steps need to be taken to ensure that the event is marketed inclusively, so as not to exclude people who don't enjoy video games. And with respect to the event itself, steps need to be taken to make sure that it doesn't exclude people who are less technologically literate or exclude people who don't have access to a good PC. In terms of the actual design event, findings from the literature and from the live event that I hosted found that it's really crucial to make sure that the event supports group collaboration, active technical support, and expert guidance to help the process go along, as this prevents participants being disengaged. And finally, while the basic requirements for the participatory modeling are met, its application will be significantly improved by a few key developments. Firstly, the game needs to add bike infrastructure, bikes, cyclists, bike lanes, everything. And second of all, the game needs to add more sustainability metrics so that participants can interact with the model and see the effects of their decisions better. This includes things like modal shifts, pedestrian connectivity, and municipal carbon emissions. These are just a list of a few. And finally, the in-game model creation process needs to be automated. It's currently manual and quite time-consuming, so automating it would massively improve its ease of use and widespread application. In conclusion, City Skylines 2 does have the potential to improve participatory planning, and my research suggests that it's actually already ready to be used in a planning application. While my research hasn't outlined a groundbreaking new technology or a new policy, it does show that we actually already have a tool that can unlock bottom-up transformation in our cities to make them more sustainable and more people-centric. And in the future, the game can actually be the game has these requirements to be used in participatory energy modeling as well, which will be increasingly important in the future, as it's not just if we are to reach net zero cities, it's not just our transport patterns need to change, but our energy and building patterns do, which will be discussed by Francisco, Laetitia, and Sara.
Hello everyone, my name is Francisco and it's my pleasure to introduce the very last part of our presentation, which is buildings. Before I do so, I want to ask you a simple question. Does anyone know what this is?
Heat pump.
It's a heat pump, well done. What is a heat pump for those of you that don't know? So this is, so this is essentially the electric alternative to gas boiler. These are 3 to 4 times more efficient than them, and they're important and therefore crucial for our decarbonisation efforts in the domestic sector. So they're key for us to reach net zero, and therefore the UK government has implemented a target to implement 600,000 heat pumps per year by 2028. Now, this number is 3 times more than what we have in total right now per year. So it gets the question you end up asking yourself is, how did we get to this position in the UK? And what are we going to do about it? So that's what I tried to research, the evolution of the UK heat pump market from a policy perspective to try assess some future outcomes for the industry. So how I did my research, therefore, was I put it into 2 parts, and I'll dive straight into part 1, which was my historical analysis. So why I did this was to understand the indirect and the direct effect that policies had on the heat pump industry so far. And by the end of it, I came up with this very complex graph, which I'm not going to ask you to understand. I've simplified it for you. Essentially, what you can see here is a full timeline of all the policies that we've had since 1994 and directly or indirectly affected heat pump uptake to date. Now, these can be split into 2. One of them is market-based mechanisms, which are supply push policies. But I want you to focus on the financial incentives, and in particular, the RHPP policy. This is a renewable heat premium payment. Since this was implemented, the heat pump industry in the UK saw a massive shift. This is when the interest started to go up. And this is what we can see here. As you can see, it was implemented in 2011. And in 3 years, by itself, it doubled the total number of heat pumps that we had at the time. The number of heat pumps that we've had installed in the country has increased dramatically since then. And it shows the importance to make heat pumps affordable, because essentially what these financial incentives are is a discount on the price of a heat pump, which are quite expensive. Now, as you can see, we stopped at 2022. Why? Because all the policies that are currently active were implemented then. And this is the same time that our current targets were implemented and our current roadmap. So this is taken straight from government. And this is a roadmap to 2035 called the Heat Pump Reinvestment Roadmap. Now, what part 2 of my research was aiming to do was essentially to assess how realistic these targets are, what the main barriers are, built up on this historical analysis, and to find the future outcomes. So again, I'll simplify the end of my research into these 4 themes. What I did is I interviewed industry professionals that are directly involved in this policy making, and the overarching themes I was able to find from these interviews are the ones you can see on the screen. Now, you can break this down into a bunch of sub-themes, and to simplify everything, these sub-themes can be shown on this word cloud to show the relative relevance. And what I was able to learn from this is the fact that there is a massive need to create confidence. Now, what do I mean by that? Creating confidence was mentioned by every single interviewer in different contexts, and it's related to creating awareness of heat pumps, which some of you didn't know about. It's related to affordability, it's related to political will, and our ability to keep these policies going beyond government changes between Labour, Conservative, etc. So this was shown as very important. Now, I could go deeper into this, but I want to talk to you about the last thing that I did from all my findings, which is what I did, which is I created some scenarios to try to assess, okay, where are we going then? To try answer these questions. Now, what you can see here is a relative likelihood of these scenarios happening. And it might seem from looking at these that the least likely is that we keep going on this low growth path that we're going on right now, and that it is most likely that we kind of have a market failure where we don't grow. But we shouldn't look at these numbers this way. Why? Because the other 3 scenarios combined have a higher likelihood of these other two combined, and these three scenarios represent a growth faster than what we currently have under the current roadmap. However, it's still not definite. There's no total consensus from either the interviews or from the analysis that I was able to make. And the conclusions that we can take from this essentially is that there's a cautious optimism in the industry. Now, I wouldn't be surprised if all of you, or many of you, have a heat pump in the next few years. But my research, what it showed is that there essentially is a lot to do still. Now, while my research was very qualitative in its nature, required a lot of policy analysis, there's other ways in which we can think or find solutions to decarbonizing buildings that are more quantitative. This is what Laetitia will introduce in her topic.
So yes, I shift more towards commercial buildings where I look particularly at HVAC systems. In case you don't know what HVAC stands for, it stands for heating, ventilation, and air conditioning, and it's a system responsible for regulating indoor conditions in buildings. So that's indoor temperatures, CO2 levels, ventilation rates, and humidity. So as you can imagine, it's crucial in commercial buildings. That's also why it's a very energy-intensive resource, responsible for 47% of the total energy usage in UK commercial buildings. So this is a significant opportunity to retrofit and optimize these systems, and which is why we've seen a rise in smart solutions these past decades. The solution I chose to look at is reinforcement learning. I assume many of you have never heard of this, and that's okay. It's a reward-driven branch of machine learning. So it learns optimal behaviors through trial and error, and is guided through rewards and penalties, kind of like how you train your dog to learn optimal behaviors through treats. It was originally applied in games and robotics, but lately we've seen more applications in control systems. But because it's a new technology, there's a lack of real-world applications, which is why I chose to implement this to a case study. I implemented an RL algorithm in a King's Lynn supermarket, where I looked at how to optimize operational costs. And the particular algorithm I used is called Q-learning, and the novel approach I included is using forecast electricity prices. So naturally, investigating the effect of forecast horizons was a particular focus of my research. And it's shown here where I have the different cost savings for different forecast horizons. But I think the first thing you might notice is that there aren't any clear trends and correlations. And while this is unexpected and unfortunate, there is still plenty of key takeaways from this. The first one is that in all scenarios, RL agent outperforms the baseline PI controller that's used. So there is an opportunity for RL to be investigated further and could lead to cost savings. Secondly, although a bit random, forecasting usually leads to more cost savings than no forecasting. So more work can also be done regarding the forecasting elements of this model. However, because these results are quite inconsistent, we can't validate the full robustness of the model, and more work can be done to investigate this. This is why we can also look at the behavior of the RL agent. So yes, this is a bit complicated, but the main takeaway here is that the RL agent has a dynamic response to the environment. So the first thing that we notice is that it can apply a preheating period before the store opens. Because when the store is unoccupied, we don't want high temperatures, and which would lead to unnecessary heating. The agent here applies heat so that when the store is open, we're already at desired temperatures, which minimizes thermal discomfort. The second positive behavior that we can notice is that before electricity prices peak, the agent applies load shifting such that when prices are high, there's little to no consumption, so very low costs. So overall, there are positive notes, notably the positive behaviors that the RL agent learns autonomously, and cost savings that can amount to 13.78% annually. But because of the inconsistencies in the model, we can't validate this model, and so more work must be done, which could either be by redefining the environment or by exploring more complex RL algorithms in the future. Once a full robust model is done, we can then integrate more complex components, such as integrating heat pumps or PV and storage solutions, which is what Sara will now talk about.
Thank you, Laetitia. Yes, installing PV photovoltaic modules and battery into building can have significant impacts. Because globally, buildings account for 30% of energy consumption, and non-residential buildings account for 11% of total emissions. So yeah, decarbonizing and enhancing energy efficiency of non-residential building can offer and help countries achieve their net zero goals. And yes, as Laetitia mentioned, PV and battery is a solution for that. However, with current market landscape, the question becomes which technology and what criteria should guide the selection of the technology. In my project, the criteria were the environmental performance measured through life cycle emissions and economic performance of the technology. To approach this project, two models were created. The first were a life cycle emission model, LCA model, where environmental impact, including global warming potential, were calculated for each technology. The technologies considered were mono and polycrystalline silicon for PV modules, and for batteries were nickel, manganese, cobalt, NMC, lithium iron phosphate, LFP, sodium ion, and second life NMC batteries. The global warming potential numbers are then used in a computational model where we calculate the carbon payback time, the total emissions, and some financial metrics, including cost payback time and net present value of the NP. As a sample of the life cycle emission results, we can see here the different impact categories, including global warming potential for different life stages, including air shipping, manufacturing, recycling, and road transport. A general trend emerged where manufacturing and air shipping were the main contributor in the overall impact, where for a specific case of the second life battery, air shipping was actually the lead contributor instead of the manufacturing. From the results also, we can see the potential for recycling to reduce the overall global impact. From this result, we use the global warming potential to be utilized in that computational model where we can calculate the total emission for the project. The cases represent different combinations for PV modules, battery technologies, and end-of-life strategies for the battery, which were repurposing or recycling of the battery. From this result, we can deduct that the operation phase where the grid is utilized instead of relying on the PV or the battery have the lead contribution to the overall emissions of the system. Case 8, where the NMC battery was utilized, have showed the highest potential from the environmental point of view, followed by case 6 and 7, where the sodium ion battery were utilized. On the other hand, economically, cases 4 and 5, where LFP were utilized, have the greatest or the best financial performance. That is mainly due to the fact that LFP have the lowest degradation rate. So for the 15-year modeling time, no replacement were required, no cost of replacement is considered, and no emission replacement are considered as well. Sensitivity analysis then conducted on the total results, showing that shifting from air to sea shipping can reduce the total emission by up to 20%. Adding 10% to the projected electricity price can double the MPV increase by up to 110%, and increasing 10% of the projected emission factor by the national grid can increase 2% of the carbon payback time. To conclude the results, the result shows that the economic and technical performance of monocrystalline outweigh the economic performance of polycrystalline silicon PV modules. In terms of batteries, while second life perform better environmentally, they have the worst economic performance. Therefore, a more balanced option has been selected, which was represented by the LFP batteries. They have the best economic performance and the second best payback time. And considering the second life batteries perform better, then considering a second life LFP battery might be the optimal solution. Sensitivity analysis also showed that sea shipping is the obvious choice for transportation, and that modeling electricity prices accurately could help influence the price. Electricity price and carbon emission would help influence the projected expectation. In terms of sodium ion, they actually showed potential both on the environmental and economic side. However, they have a technical issue, which is the high degradation rate. So that during the 15 period, we need to replace the battery twice, which add to the cost and the emission embodied with the sodium ion. As it's still an underdeveloped technology, in the near future, it might be proved to be a better solution. In the end, to conclude the project, it has been proven that the selection of the technology is site and project dependent. However, this project will present a framework for decision making in the UK for business owner on what is the best technology. And now, Laetitia will conclude our presentation.
So I hope this research today has shown how we can achieve sustainable living. We must change the way we approach our cities, our transport, and our buildings. To reach net zero targets, we need both behavioral shifts and advancements in technology. In transport, this translates through the adoption of SAF, the upgrade of bio-oils, or the electrification of road transport. It must all be paired with financial and regulatory support. In cities, innovative planning and integrated policies can drive the shift to active mobility and push for smarter developments. In the built environment, regulatory frameworks will also encourage the uptake of low carbon technologies, which in turn must also be paired with smart solutions to help reduce our carbon emissions and to optimize building efficiency. In summary, policies, technologies, and clear planning are key drivers that will reshape our transport, cities, and buildings to shape a sustainable future. Thank you for listening, and please let us know if you have any questions.
We can have one or two.
Hi, I have a question for Francisco. So you mentioned that the policies in the UK haven't been great historically for heat pumps. Are there any other policies that European nations are doing that the UK could copy?
Yes. There's a lot of things that the UK can take from. For example, Norway was very early on approaching the heat pump market. Germany, for example, has managed to address one of the main issues, which is the spark gap. This is the difference between the electricity and the gas price. It's extremely key. The UK is really, really high. That's essentially what we need to try and achieve. A couple of other countries are doing it. Now, the way in which you do it, you could try finance that shift via taxation, essentially. You could try finance that shift via the shifting of the levies to gas instead of electricity. You can use private capital. It just depends. It depends on what works for each country, and it also ultimately my research was very influenced by political decisions. Government thinks it's going to get votes, and unfortunately, sustainability doesn't a lot of the time, at least historically anyway. Maybe more. There's a lot of things you could talk about, but I don't want to bore everyone with a bunch of policies from other countries.
Sorry, mine's also a heat pump question. Just whether the fact that the UK actually uses for residential water-based radiator systems, which I think I gather is quite unusual, and so you aren't tapping into a lot of the learnings which other countries have air duct type systems. The US, for example, where it's actually successful and easy to install a heat pump. Whether that's been a big contributor for the UK.
Yeah, well, the UK's housing sector is the oldest in the entirety of Europe. So I didn't mention this in the presentation, but the top line of the policies that you saw, the market-based mechanisms, those are oriented at pretty much retrofitting homes. So they are fit for these heat pumps, essentially. Well, not directly for the heat pumps, but it helps, essentially, because they're so old. It affects how effective these heat pumps are. So it definitely has had an impact. The fact that UK homes are, in general, not prepared to have them. The solution the government has found is to keep improving homes such that it's easy to implement this heat pump in the future. But it's kind of the next thing they're trying to do is to basically the new homes they build to make them heat pump oriented, essentially, to not have them connected to the gas grid at all. But we'll see how that goes because we implement it next year. So.
Thank you for your presentation. My name is Yohan Kumanovic, and I'm a senior fellow in the Department of Chemical Engineering. Most of your presentations were amazing, but something that caught my attention was the share of hydrogen and bringing down the emissions from the aviation sector. And what I saw is that was kind of the lowest compared to SAF. So is that based on the share of hydrogen in the global mix, or it's based on as a technology? So I'm just curious to find your assumptions on that. Thank you.
So basically, the numbers were based on the state of hydrogen in Europe. Literature has shown that scientists are optimistic about hydrogen being ready by 2035. So in the model, basically, there was no share of hydrogen between 2025 and 2035. So basically, it was literally zero. And from 2035 to 2050, there was like a 5% increase per year, I mean, for 5 years. So when you just calculate that in total, that's why it's the lowest, not because it's not efficient, but mostly because it's not ready yet. And even 2035 is not really, and it's not really final data, I would say, like it's mostly like assumption, but that's mainly why it's not that efficient, not because it's not efficient in itself, but just because it's like a late implementation. Thank you.
I'm sorry, but because of time, we need to move on.